So let me start. I'm the CEO and co-founder of Ligero. I also am an associate professor at Georgetown University, currently on leave. This is some of the work that we are doing at our company, Ligero. Ligetron is the new version of Ligero, which was published last year in IEEE Security and Privacy. It's essentially the same blueprint as the Ligero system that was published back in 2017, except that it is memory efficient. It can run directly from the browser. But first, I want to walk back through sort of a biased view of history. So that's actually my dad. He's sitting on a punch card system while he was working at Tata Institute of Fundamental Research in Bombay. He was computing something on weather data at TIFR. He used to tell me that these punch card system, you need a lot of discipline. You write your program, you punch it in the card, you give it in the morning, you get the results in the evening. You don't know if it was right, wrong. You can't change it until the next day. And to me, this it's similar to like Groth16 and SIRCOM with trusted setups. It's some of the most used technology we have, but once you set up the circuit in your trusted setup, changing it is heavy. My dad, he taught me everything he taught me programming, and he passed away in with COVID in 2021. But the first machine I used was the IBM PC XT machine. It really looked like that. You got to take a 5 1/4 floppy disk with the operating system DOS, plug it in, wait for it to boot. Actually, the first programming language I learned was COBOL, and I also learned BASIC, which is a programming language on this system. And we all still, there are many parts like the financial system as well as the government, as I hear, still use COBOL. Again, just tracing through history, we started off with punch cards, then came COBOL and Fortran, which I want to say has actually survived through time quite a bit. Then we got, the more popular, which is, still popular, the C, C++. We got the Unix operating system, PCs, etc., and then object-oriented programming. I should also tell you, my dad taught me Smalltalk, which was one of the first object-oriented programming language, which I think was invented in the 80s. But then now, Golang, Rust, this is very popular. And today, I want to talk about the next evolution of this, wipe coding. So what is wipe coding? And I actually didn't know this until a few months back. This is Aravind Narayan. He was my high school classmate. He's a professor at Princeton University. He started out as a theoretician. Now he, does a lot about AI, demystifying what cannot be done with AI. And I saw this post he did on LinkedIn where he said he could code web apps in minutes. He could build an app for his kid to teach fractions, etc. In fact, he even had the app linked on in the LinkedIn, and I went and I looked at it. It was a simple app. It was really, really good. Then I heard of this term vibe coding, which was apparently coined by Andrej Karpathy. I have huge respect for him. Come and ask me later, in the industry. He said he could start coding applications without touching the keyboard. Just talking to things, talking to your LLM, generating code, then just deploying this. You just forget that code even exists. So let me show you a video of me of the first apps that I did using this kind of vibe coding. Let me talk to you about the first app I created. After seeing my friend's blog post for building use and throw apps for his kid, I was like, I'm going to do the same for my 5-year-old daughter who's learning addition and subtraction. Here is a simple app. You can practice addition. You can give your answer. It counts score. To keep my 5-year-old daughter engaged, who's obsessed with Frozen, I added a voice where, when you give the right answer, it uses Elsa or Anna's voice to say yes or no. And if you give the wrong answer, it's going to say
No.
No. Once I did addition, doing subtraction was easy. I wanted to say, setting up the first one took about 1 to 2 hours. I had to set up the base, post it on GitHub pages. But once that was done, the subtraction, for example, took literally 10 to 15 minutes. After I did this, I was like, okay, what's next? So getting into zero knowledge, here is a simple extension of the app I did. This does, addition, modulo, primes. Here is the simple SHA generator. It just generates the SHA-256 of any text that's typed in hex. Once you have a hash, you can build Merkle trees. Here is a nice visualization of generating a Merkle tree on the fly. As you can see here, as I type, the root gets updated. Furthermore, you also see the path from the leaf to the root that gets updated. I did all of this in Claude, so I thought, okay, why not try doing something in ChatGPT? So here I'm doing another Merkle tree visualization. Again, I give the data elements in the leaves of a Merkle tree. And generate. Here is the Merkle tree with this being the root. I added an extra feature here where when I click a leaf, it gives me the decommitment. If you recall, this is what is needed. When I want to prove to you that a certain element sits at the leaf of a Merkle tree, I have to give you the siblings along the path from the leaf to the root, and that gets displayed over here. This can become really a very easy teaching tool for anyone, to generate these apps for every day for your lectures. Once I did Merkle trees, the next what is used in Ligero is pack secret sharing. Most of you would call this Reed-Solomon encoding. You give the secrets, it pads with randomness because it needs to be secret sharing, generates the coefficients, the evaluation, and then I pick from the evaluation points outside of the domain used for the secrets, and that becomes the encoding. That's it. And once I got going, it was just easy to build the next app. If you haven't tried vibe coding, I will tell you, this isn't hard. I used to code a lot when I was in high school, a little bit in my undergrad, of course. But then for a long time, I was a theoretician. But then I got back to this. It's really empowering. They give you really a base for launching these apps, and then you can just ask it to generate an app, and you can deploy it on a GitHub page, really in a matter of minutes. The first time, the setup will take time, but then after that, it's pretty fast. So let me switch gear a little bit from vibe coding. Why we are here? We are here to talk about zero knowledge proof systems. So I'm going to talk a little bit about what is knowledge. Now, knowledge is a question as old as humanity, and it's been pursued in philosophy under the branch of epistemology. Also, neuroscience, psychology, economics, all of this care about knowledge. More recently, I want to say the last couple of decades, you want to capture knowledge for artificial intelligence, or lack thereof for cryptography. I want to talk about the people who invented zero-knowledge systems, Silvio Micali and Shafi Goldwasser. They did win the Turing Award for laying the foundations of modern cryptography, but also for zero-knowledge proofs. And it's important that, to capture even the security definition of zero knowledge takes a lot of work. And I have one slide. This is probably the most technical slide I have. The foundations of knowledge itself was first done in something called probabilistic encryption. To define what knowledge an adversary gains from looking at a ciphertext was there in these works. And then, of course, it was refined in their work of zero knowledge proof systems. And this is really the essence of what they did. They defined zero knowledge without actually defining it. This is the best I can actually really tell you about this. The way they capture knowledge is not that the data you have, it is about what you can feasibly compute from the data you have. And really, feasibly compute has two things. You're bounded by a computer or a supercomputer or tons of 4090, but you can execute this for bounded time. And you have randomness. Really, these are the things that you have. And what you can gain from computation on data using these resources is knowledge. Things that you can't do in this is considered hidden from the adversary. So coming back to zero knowledge, it's about generating a proof to the verifier that it learns no additional knowledge beyond the input statement or the public inputs that you're giving to the verifier. And really what this means is that the verifier can learn nothing more than what it can compute from this input statement that you give it. And I think this is important. I mean, I am the biggest fan of zero knowledge proof systems, but you also have to understand what is really the privacy it gives. And especially when we want to deploy this in privacy-focused applications, this definition in mind is important. For example, if I prove to you today that I have a commitment of my salary, etc. I prove to you that my salary is at most $100,000. And then a few days later, I come and prove to you, hey, my salary is more than, $99,000. Now, really, combining these two proofs, there was nothing to do. Even if you use the perfect zero-knowledge system, you all have a pretty accurate version of what my salary is. So you need to know what privacy is guaranteed by zero-knowledge proof system when you deploy it in the open. Okay, that's it with me preaching about zero knowledge. This is a little bit outdated version of the ZK landscape. Maybe you should look at ZK Mesh. It has the latest version, the latest list of all of these. Don't squint your eyes looking for your project. Even Ligero is not listed over here. We have a lot. We have a lot of effort, a lot of investment, a lot of protocols being developed in this landscape. But I kind of want to say that this promise of ZK for privacy is, still a promise. It's still a niche. And here I have a list of reasons. You may or may not accept this. Maybe we don't care about privacy. And I'm sure a lot of you have faced this, running zero-knowledge companies. You go talk to people. They're like, yes, I care about privacy, but that's not the first thing I'm going to do for my stablecoin. That's not the first thing I'm going to do for my DEX. The PMF, the real PMF, is probably not yet identified. And Starks and Starkware have done a tremendous work in this industry, bringing really zero knowledge to the masses. And, pretty honest, most of the implementations are Starks, and, they're not zero knowledge. More than, I would say, 90% of these things don't come to the formal definition of zero knowledge. Not that they are insecure, they aren't, but I want to say Starks themselves are not. And there was a beautiful work and presentation by Ulrich in ZK Proof 7. They are really working hard. It's a lot of pain, but they're working to make Starks ZK. And maybe DSL is a barrier for adoption. We have all these languages, CIRCOM, NOAR, Cairo, etc. Is it that we are not able to get developers in this space? There is this threshold of learning a new language. And the last point is also true. Most of the performant zero-knowledge systems we have today requires heavy hardware, a lot of GPUs, a lot of memory. So is this what is stopping us from making, ZK for privacy? So just going back to this, and take whatever I'm saying with a grain of salt, it's just my view of these things. I look at R1CS and, as sort of punch card systems, and CIRCOM, improving this to languages, and, Cairo doing the next generation, and now we have zkVMs. We can take a Rust program and be able to generate a zero-knowledge proof of this, of what this program is computing. And one should think, right? If I can do zkVMs, I should be able to do wipe coding. What is wipe coding? An LLM generating a code, I should be able to plug it into one of these systems and do it. And this is what I saw after I did all these wipe coding examples. I was like, this is my obvious next step. But before I go into showing how, like, I have a video of me wipe coding for zero knowledge, I want to talk a little bit about Ligetron system. So the Ligetron system, as I mentioned to you at the beginning, it follows the Ligero blueprint that was done in 2017. But it is the only memory-efficient hash-based zero-knowledge system today. I want to clarify or qualify what I mean by memory efficient. It means that, like, for example, we are a zkVM with the underlying VM being WebAssembly. We want our prover system to use roughly the same memory if I had run the underlying WebAssembly program, which would be like, if you know the WebAssembly semantics, it would be the maximum stack height that it would need and the memory RAM that it uses. And this is achieved by the Ligetron zero-knowledge system. Ligetron is zero-knowledge by default. I know I stress this point, but there isn't a knob. It's not a snark. It's like, it is a ZK snark. And finally, once we got this memory-efficient version, we wanted the capability of people to build applications and deploy it anywhere. Anyone should be able to run it from their cell phone, from their laptop. And we also wanted it to be scalable. Had we implemented our current version with CUDA, I'm sure we would have gotten more performance, but this is not going to be useful on a cell phone. So we kind of restricted ourselves and said we are going to do this on web GPUs so that anyone should be able to run it from their phone or from their laptop. And for that matter, even Raspberry Pis actually have GPUs today. And this was a really surprising announcement. Well, okay, I shouldn't say surprising, but this was an announcement recently that Google adopted zero-knowledge systems in their wallet. And really what they're doing is you have these things called mobile driver's license that are issued in like 11 states in the United States, and Europe is moving to the EU ID similarly to offer credentials to their citizens. You can put these digital credentials, you can tie it to your cell phone, and then you can prove to anyone things about your credentials in zero knowledge. And really, the application we talk about going into a bar and saying that you were 18, you can literally do it with this project. What was nice is that the team behind building this Google Wallet ZK tried different system, and they chose a combination of the Ligero system and the GKR system to get something that would run from a phone. So this actually, they have tested this. It runs in a couple of seconds. It runs from an Android phone. I want to say that on our platform, we'd be able to implement this, and you'd be able to run it from a browser, not just from Android, but from anywhere. And they used the work that was published in 2017. Most of their work was based on it. They are not quite memory efficient, but their circuits are small enough that they would run from a small device. But our system, we would be able to prove much more complex statements about your identity, maybe multiple identities, through our platform. All right, so enough of all of this. Let's wipe code with Ligetron. I have maybe a 5-minute video. I apologize. Next time, maybe I'll try to insist on doing a live demo, but bear with me with this video. Let's wipe code with Ligero. I want to walk you through our platform just to see how you can run applications from our platform. Recall that on our platform, you can build and deploy completely from within the browser. No tedious GitHub cloning, etc. You can write your C program, compile, deploy. Go to platform.ligetron.com, sign in with your Google credentials, and now you will enter a marketplace where people have developed some applications. I'm going to pick one of them, edit distance. You can look at the source code to do edit distance computation. This program is showing that the edit distance between the first two strings are small, where the first one is private. It's generated the proof. Now you can send this proof, verify this proof on this browser, on another device. That's it. I'm going to show you later how to create projects, etc. But let's start coding. Here's ChatGPT. I'm going to give it some basic instructions on some function headers, how to do SHA, how to do assertions, etc. And then I'll be ready to give its instructions to generate the first program we want to prove in zero knowledge. All right, here's my instruction. Write a C program that takes in 3 input strings from command line. The second and third inputs are public. The program computes the edit distance between the first 2 strings and asserts the distance is less than 10. It checks if the SHA-256 of the first input is the third input. All right. Now let's wait for it to create a program. All right, here it's generating the code for edit distance. Checking the hash, and done. Now I'm going to copy this. Let's go to projects. I'm going to create a new project. I'm going to call it edit distance vibing. I've copied the program, copy it down here, compile. It's generate a WebAssembly file, which is our intermediate representation. We are a zkVM, and now I need to give it 3 inputs. I'm going to give it I'm going to mark the first one as private, just like before. I need the SHA of this, so I'm just going to use online SHA generator to get the SHA. I need to mark that the third one is in hexadecimal and prove. This circuit has about 20 million gates. It has generated it in 6 seconds. Done. So let's do another program.
Just one more.
Write a C program that takes 2 integers n and m as input from command line, where the second input is public. It asserts that the nth Fibonacci number is m, where Fibonacci is computed using an iterative algorithm. Right, now let's see. I'm going to copy this program. Let's go here. We can use the same code base. I'm just going to do that. I'm going to copy the new one. I'm going to hit compile. And now this new program has only 2 inputs. So it's going to be 20. I think the 20th Fibonacci number is 6765. I need to mention that these 2 are integers. And let's hit prove. That's it. And let me try a wrong number and see what happens. I get the answer is false.
You need to make sure that the zero knowledge system
you can
is
go to a marketplace. Many of them actually I did try to generate it using ChatGPT. Battleship being one of them. It checks if the placement of your ships is correct, as well as whether it's a hit or a miss. I've also tried a little bit with some regex. Thanks.
All right. Thanks everyone for your patience for having watched this. I want to say that this is really within the realm of what we can do. We can make this a co-pilot where you could just directly give instructions to our platform to generate this code. I think it's not hard to see. We could even do the Google Wallet identity thing by saying, hey,
you need to parse an MDL, which is an ISO format, and verify an ECDSA signature and check that my age is greater than 18. This should be really, possible to do it on our platform. The Battleship is another example. I couldn't get that on the video, but I want to tell you, this is what I did with Battleship. I went first, I vibe coded, I generated an app to play Battleship. I'm probably dating myself. Many of you probably didn't play Battleship, but I could create an app to play Battleship, by just opening 2 browser pages and doing this like in a matter of 20, 25 minutes. And I also vibe coded to generate the predicate to verify the instructions. Now, you could play Battleship peer-to-peer over the internet where, each person commits to their inputs, their input plates, and then they cannot lie whether it's a hit or a miss. And I didn't integrate them together, but I have both of these codes separately. All right, so a little bit, our mission, we want to make ZK useful, usable, all running on your device. Just a word, we are trying to solve privacy, compliance, decentralization. We're trying to build tools where people can prove compliance themselves. We talk about self-sovereign privacy. What we want to do is self-sovereign compliance. We're going to do this by, ZK Validiums offer a lightweight form of privacy when you have service provider launch their own networks. And you can get compliance by having these predicates on our marketplace where people could prove for different jurisdictions what they want to establish for their own, respective state jurisdictions, countries, what kind of compliance they want to do. So we imagine that, eventually we'd be able to just have like a marketplace for all these compliance conditions that could be integrated directly into your network. You want to test, you can go to our platform. There is a speed test you can try out. If you have an Apple machine, you have to, web GPU is still like in the trial phase. You got to go and set the feature flag for web GPU. So this is what I want to say. At ETH Denver, I have this. I'm going to modify the slide. It's not the same slide. I talked about building, in the browser, building in any language. But today I want to say vibe anywhere. Like you don't need to even think. Forget that code even exists. Thank you.
Awesome. Thanks. Right on time.